Hello, we're going to be looking at our Section 2.6 project about investigating translations. Now, when we did this project in class, we ran into a number of challenges, and only some of them had to do with the actual trigonometry that was going on. I gave you this Word file as an attachment to an email, and asked you to go through here and work through the Word file and replace or type in to the Word file answers to the questions that we have here, including importing some graphs from Graphmatica or some other appropriate online place. So I'm going to take this and I'm going to work through at least part of the way through the solution set here, and I'm going to just leave the recorder going. I'm going to kind of explain what I'm doing as I'm working up an answer key to this. And you can use this to kind of help you not only see what's going on with the trigonometry, but also working with the Microsoft Word file a little bit. Right here, be sure that when you're working with graphs of trigonometric functions and inverse trig functions a little bit later on in the course, be sure that your calculator is in radian mode. So let me pull up my calculator here. I might want to use this a little bit later, and I want to make sure that it is in radian mode before I get going. Now, Graphmatica starts essentially in radian mode all the time. So if I go to mode, okay, we're in radian mode. And so if I need my calculator to compute anything, I can do that. Okay, so this first set of problems here, it uses an algebra example just because the arithmetic part of it's a little bit easier to work with. The transformation part's exactly the same. So let's look at this. You know what? I'm going to take off these subscripts here. So we have y equals x squared and y equals x plus 6 squared. So what happened to the formula? So this first blank, when it says replace blank by blank, that first blank is always either x or y. Now if you look at it, they both have y equals. So the y side did not change. It's the x side that changed. So I've replaced x, okay, by what? Well, everywhere there's an x in the one on the left, I've replaced it by a set of parentheses, and in that set of parentheses I put x plus 6. So that's what happened to the formula. So in the formula, I've replaced x by x plus 6. Okay, so since this is a change in the x's, we're going to set up this table in such a way that the y coordinates are left alone. Okay, so the y coordinates are not going to change. Okay, by the way, notice what I'm doing. I'm just typing in some things. Notice I was able to use things like I was highlighting something here. I used bold and underline. These things I can use to change the format. So we're going to leave the y coordinates alone, and what are we going to do to the, which coordinates are changing? Well, it's the x's that change. So it's the x coordinates that are changing here. And what are we going to change? How are we going to change the x coordinates? Well, you're going to see that the way these work is you actually do the opposite of what it looks like. It looks like you're adding 6 to x. What you're actually going to do is you're going to be subtract 6. Let's say instead of 2, probably from is a better grammar there. So let's fix that. Subtract 6 from the x coordinates. So let's do this. Now, to fill out this table, I've given you some specific x values, and we're using the formula y equals x squared to figure these out. And I want to figure out the y. So the formula is just square the y's. So I just type in the boxes here. Negative 7 squared is 49. Negative 6 squared is 36, and so forth. I don't need a calculator for this, although this would be pretty easy to do in the calculator as well. Oops. Okay, I believe I have those in there correctly. Now when we do this, we want to set these up. I have a table here that's going to work for this second equation. Now I don't want just any table. I want a table that works for this equation, but also one that's lined up, so that right here I have the image point of that pre-image of negative 749. In other words, well, for example, this point 0, 0 we know is going to be the vertex in this graph, and this one over here will also be the vertex that it gets mapped to. So each point here will be mapped to its corresponding point in the other graph. So I don't want just any graph, but one where the y's are the same. So notice how I just highlight all that. I can right click and say copy, or a shortcut is Control C. And I can go over here and highlight the part here, and Control V is paste, or right and then paste. And there's some different options on paste. So what it says to do here is leave the y coordinates alone, which is what I've done, and I'm going to subtract 6 from each of the x coordinates. So negative 7 minus 6 is negative 13. Negative 6 minus 6, negative 12. Negative 5 minus 6 is negative 11. And I think you can see, since the ones on the left are going up by 1, these will be 2. And we can see this setup here. Okay? Now, let's actually graph this and see what happens. So if we take, well, let's do this first. Let's predict something before we actually graph it. So if we look at this, first of all, I've said these are the points. Let's see if they really are. This has to work in this equation up here. So let's say, let's try this, negative 7, 1. So negative 7 plus 6 is negative 1, squared is positive 1. So that worked. Notice when I took the negative 7 right here and I added 6, I was back over at this x, negative 1. Now squared, I'm at this y, so that this y is the same. Similarly, let's take negative 1 here. Negative 1 plus 6 puts us at 5. 5 squared puts us at 25, so our output is 25. And so forth. You could check all these points and you see that that actually is the table. Now let's graph this. Of course, we could graph this on a graphing calculator, but we can also graph it here in Graphmatica. Now the way Graphmatica works, first of all, notice how I've done some settings. So let me just do that first. If you go to View and now go to Options and Graph Paper, I can use a trig scale if I want. Look what happens when I do that. We get multiples of pi along here. For this one, I don't want that, so let's go back. That might be useful later on. We just want a rectangular grid. I want a solid grid because I don't like dotted lines, but let me just show you what you can do. You can have dotted grid lines. Oops. Like that, if you like that better. I don't really, but you can if you like that. You can have just dots at the corners of your grid like that, or you can actually just the other option is to turn the grid off altogether and just have the axes, and you can have it draw the axes or not. You really kind of have to have something there for axes to have a reference point, but I like a solid grid. And then for colors, if you start with this white back thing here, this will give you the basic thing, but you can actually go in here and change things, like the background is white, the border I have a dark red, the axes are a dark red for me, or they can be. I don't think they were before, but let's say that they're dark line. The grid lines, I usually like to go with some kind of a dark gray or something. Actually, in the axes, I usually like to just make them black. Okay, and then you have different graphs. So the first graph might be blue, and then the second graph might be red, and the third one maybe a dark green, and the fourth one, let's go with the bolder colors first. A dark blue, and then a dark red, dark magenta, that's good, and then next to the dark red, and then I don't know, maybe magenta. And so we can go to these things, and let's say we'll make these the default. And so now I have a basic grid. If I go to view, I can click on, I can hide or show these scroll bars. I like to show the scroll bars like that, and so you have bars on the sides that you can just kind of move around. You can also adjust the graphing window by changing things like go to view, grid range, and this is like setting the X min and X max, Y min and Y max on your calculator. So anyway, we have this. Now, to type it in, that's all cosmetic stuff, but you know, sometimes it does make a difference in how things look. So when we get back to this and we want to actually graph it, we want to graph y equals x squared and y equals x plus 6 squared. And in Graphmatica, you just type in the equation just like you see it. Y equals x squared. Notice we use the little caret just like you do on the calculator for power. And there's y equals x squared. Now I can go in here and replace the x by a set of parentheses, and in the parentheses I put, was it x plus 6? Yes, it was. And now I graph that. So which way did it go? It actually went to the left. So notice that you get corresponding points. So for example, this point at 1, 1, the corresponding point now is at negative 5, 1. And if you look, that's what we said right here, that 1, 1 is at negative 5, 1. The vertex was at 0, 0. Now the new vertex we've set here is at negative 6, 0. Sure enough, there it is. And so we see that the graph, when you add negative 6 to the x-coordinate, leave the y alone, each corresponding point stays the same height, but is just shifted to the left 6. So let's describe that in words. The new graph is the same as the old graph. Let me use a better word. The new one's called the image. Image graph is the same size and shape as the pre-image, that's the old one, graph, but is, okay, the technical term is translated, 6 units to the left. So other words you might use might be slide, scoot, shift, okay, but it's basically the same. So 6 units to the left. Now let's get the graph in here. I can press this copy graphs button, and or I can go to edit, copy graphs as an enhanced meta file, EMF, and I have a choose to do color or all black and white. I'm going to choose color. And I'm going to go over here and go right here and go paste, which is Control V, or I can right click and select paste. Now I can click on this and make it a little smaller so that whenever so I can get both graphs in here, and you can see it that it's actually 6 to the left. Alright, now that we've done one, it should be a little bit easier to do the next one. So again, on this one, what's changed? Well, again, it's the x that's changed. And we replace it by x minus 2 this time. So we replace it by a set of parentheses with a x minus 2 there. And in the table, which one are we leaving alone? Well, we're changing the x, but we're leaving the y coordinate alone. Okay. And the thing that we're going to find on all of these is that the, oh yeah, I'm going to make my answers red so that you can see what was the solution and what was the original. So the we see over here that the x was changed, not the y. So I need to use the table to make a set of y values. Well, it's the same part as over here. The original function is the same. So if I go over here and copy and paste, Control C, Control V, okay, and notice it is the y coordinates that are the same as the x coordinates are changed, and we're going to notice it's backwards. So I need to add 2 to the x coordinates. Okay, so again, I'm going to line the table up in such a way, pre-image to image, so corresponding points line up. To do this, the y values are going to stay the same, and I'm going to add 2 to all the x's. So negative 7 plus 2 is negative 5. Add 2 to negative 6, you get negative 4. Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all just adding 2 to the previous one. Let's check it. Let's pick a couple points at random and check. How about 5, 9? 5 minus 2 is 3. That puts you right here. Then square it, you get 9. So the same output here is 9. Let's check a negative one. Negative 3 minus 2 is negative 5. Negative 5 squared is 25. So the negative 3, once you do the first step of subtracting 2, you're at negative 5. Then you do the squaring step, which puts you at 25. And so that's the same output over here. Okay, so let's see. So once again, it's the same size and shape as the pre-image, but what is translated, shifted, scooted 2 units, and this time it is to the what? To the right. Okay, let's see if that bears out on the graph. It should. X squared equals x squared and x minus 2 squared. So I can go back to my Graphmatica. I can clear the whole screen if I want here. Clear screen doesn't seem to be working right now. I did there. Okay. Y equals x squared. Draw that. Click on this to see my original. Change it by replacing x with a set of parentheses, and in that parentheses put x. Which way was it? Minus 2. So when you see x minus 2, you're really adding 2 to each x, leaving the y alone. That should shift it to the right. And sure enough, there it is. Copy that. Paste it here. And let's make it a little smaller so we can get them to both fit. Okay? Alright, now let's do the next one here. I'm going to get rid of these subscripts, just indicating these are different functions, but they're still just y, so I think it may make that a little bit easier to understand. Okay, so notice on this one right here, we're looking at y equals sine of x. Okay, let's just start by graphing that. Okay, so let's clear this out. And let's go to our graph paper and let's put it on a trig scale. Okay, put the origin somewhere in the middle there, and this is a square scale, so it's not going to be distorted. And we're looking at sine of x. There's our sine wave. Okay, notice it starts at 0, goes up to 1 period all the way to 2 pi, then it repeats the wave again. Halfway through the wave, you're at 0 again at pi. Halfway between 0 and pi, you're at pi over 2 for x and 1 for y. And between pi and 2 pi, we're at negative 1 for y. So there's our sine wave. Of course, we could also relate this back to the unit circle picture. Now, take this and let's look at some table of values here. Let me get to what I want here. Let's relate this back to the unit circle picture a little bit. And let's say if we go here and we look at sine, and there's the graph, notice that when we start at 0, we should be at 0 for output. So that's a y value of 0. So for some reason that's going sideways. It shouldn't be, but let me see if I just take this one and format that and paint it there. No, it's not doing it. So I'm going to highlight that, and there's a text direction. Let's see. It's either design or layout. Let's see. Layout, text direction. There we go. That's the right way. And let me just paste that here, mainly just to get the formatting right. They may be actually different. I'll delete that. It may not be what I need there, but I don't know why that one was turned sideways, but it was. But that does show you can run text going up and down in a table if you'd rather. Okay, so well, I said 0, 0, that's where we were doing here, but it's also true at 2 pi and negative 2 pi, because those are just different rotations around the circle that end in the same place. Now let's do some other easy ones first. What about if you're halfway around the circle this way? Well, again, the y value is 0 there, so that's a 0 on the sine wave. So that happens at negative pi and pi, and among a lot of other places, odd multiples of pi. Now what about halfway in between there where we have right angles with the x-axis? Okay, that would be like for here, pi over 2, that's at 1. Okay, it also happens over here at 5 pi over 2, and at negative, let's see, negative 3 pi over 2. So here it's at 1, so we start at 0, go up to 1, back to 0, down to negative 1 here, back up to 0, back up to 1, down to 0, back down to negative 1, and then back up to 0 again. So these negative ones happen when the angle is here, and that's, for example, at 3 pi over 2, when it's straight down, or at negative pi over 2. So on our graph right here, or right here. Okay, so I'm just kind of halving this up. Okay, so now let's half it up again. And so halfway between 0 and pi over 2 is pi over 4. Well, what's that going to be? Well, if we go out a little further, well, actually to this point right there, we get this is 1, and that's square root of 2. So we get the cosine is 1, or the sine, either one actually, is 1 over square root of 2. By the way, that's where the cosine graph and the sine graph are going to cross each other, if I get it just right there. Okay, one of the places they're going to cross anyway. And so that is 1 over square root of 2. That's using one of our special triangles, 1, 1, and square root of 2. And it is positive. So in our table, this is 1 over square root of 2. Okay, now to get that, let's go to insert, and we can insert an equation. And we can type an equation. Let's make it a fraction first. Let's make it a fraction like this. And in the top of our fraction, we can write 1. And the bottom of our fraction, we can go down here and enter a radical, a square root, and in that we can write 2. And so that's the exact value. And let's say, let me put an approximately equal symbol outside that. Let's see. There we go. Approximately. I'll just type in here. So here I'm going to use my calculator. 1 divided by square root of 2. Of course, you could write that as square root of 2 over 2 if you'd rather. Notice if I do square root of 2 divided by 2, same thing. And so 3 decimal places, 0.707. Okay, so there's an exact value. At negative 5 pi over 4, I'm sorry, that was at negative pi over 4 here. So same thing, 1, 1 and square root of 2, but the x value is positive, the y value is negative. So in fact the sign is negative in that quadrant. So let me copy this whole thing. This is what should have been put at pi over 4. But at negative pi over 4, this should have a negative in front of it. Oops. And the remaining ones I've got to fill out are one of those things. They're one of these two things. So at pi over 4, we're here, up here, sign's positive, sign's also positive over here. Okay, so that's at 3 pi over 4. Is also positive there, so we can copy this whole cell, Control C, paste it here. Then these are negative down here, so this one will be negative here and here. 5 pi over 4 over here in this picture. Let's count pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, somewhere in here. So that sign is negative. 6 pi over 4, 7 pi over 4, somewhere in here, that's negative. Let's go in the negatives. Negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4 is also negative. But negative 5 pi over 4 is back in the second quadrant, and that one and that one are positive. And so now I have the whole table filled out. And so we have some x and y values there. Okay, now this is just getting a table for y equals sine of x. We have exact values for x and exact values for y, and approximate values for y as well. Now how about the new graph and the new formula? Well, how about the new formula first? What changed? Notice it's still y equals, that stayed the same. We're changing x. We replace x by, so if I took this formula and everywhere there's an x, put a set of parentheses, and in that parentheses put x plus pi over 4. Okay, now I can do this a couple ways, but let's say I go to insert an equation and I want a set of parentheses. I go here and say parentheses x, whoops, the x needs to be inside the parentheses, x plus, now we want a fraction. Let's do a small fraction like this, and the top is pi. Let's see here, where's pi? Here we go, pi, and then this is over 4. Okay? That underline didn't do so well, I'll leave that alone. Okay? So, once again, we're leaving the y coordinates alone, and we're changing the x coordinates, and we are saying, we'll change to from, and subtracting, well, if you just want a pi, for example, you can go to insert a symbol, pi over 4 from the x coordinates. It takes a little while to do this, to typeset everything, but not a whole lot longer than writing it out. Okay, so we want to do this in such a way that the y coordinates are alone. So once I've got these, I can paste them here and here. This is a different formula over here, so we'll get to that one in a minute. Okay, but what do I need to do to the x values? Let me just take all the x values that I have and copy and paste them over. But they're not right now. I need to fix it. What do I need to do? I need to add pi over 4. Well, I need to add some fractions here. Negative 2 pi over 4 . Okay, now let me look at it, be sure I'm doing this the right way. I'm subtracting pi over 4. Okay, adding a negative pi over 4, or subtracting pi over 4. And the original was just negative 2 pi. Now what I want to do is get a common denominator, so I'll multiply this by 4 over 4. I get negative 8 pi over 4 minus 1 pi over 4 is negative 9 pi over 4. So that's my new one. And by bringing that over, negative 9 pi, and just say over 4, I could do it like that. Negative 7 pi over 4 minus 1 pi over 4 is negative 8 pi over 4, which is negative 2 pi. Oops, I shouldn't have taken the pi out. Control Z will undo. And the next one is negative 3 pi over 2. Negative 3 pi over 2 minus pi over 4. Okay, multiply top and bottom by 2 over 2. So it's negative 6 pi over 4 minus 1 pi over 4 is negative 7 pi over 4. Wait a minute. Did I do what I want to do? Negative 3 pi over 2. Yeah, this one. Negative 7 pi over 4. Now at this point I want you to know something. Notice that these numbers are the same as these first two up here. This is already going up by pi over 4. And so when you subtract pi over 4, it's just shifting it. So in fact, I could actually copy this, all but the last one, and paste them to here, and it's going to work out correctly. Let's check out a few of these. Pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. Sine of pi over 2 is 1. And notice that does sign line up. The pi over 4, you subtract it, you get to pi over 2. Do its sine, you get 1. And that works out. You can check out some more on your own, but these do work out correctly. Okay, so what do we actually do in the graph? Okay, well, actually this is kind of the same. Let me copy and paste here. Copy and paste can be a big help. Okay, the image of graph the image is the same size and shape as the pre-image, but is translated pi over 4 units to the left. here's power 4. I'll just copy and paste that. Power 4 units to the left. Okay, so similarly, over here we're going to replace x, okay, by parentheses x minus 3. Let me copy this and paste it here. But I need to change this to subtract, and this needs to be over 3 instead of 4. Use my arrow keys till I get where I want. Okay, so we're going to leave the y coordinates alone. So that's the same. And do what to the x's? This time it says x to x is replaced by x minus power 3, so we're not going to subtract, we're going to add pi over 3. So the formula is backwards, remember, to the x coordinates. Alright, now we get a lot of these same numbers here on the cosine, but remember when you're looking at a cosine graph, let's see, turn that one off. Here's the cosine graph. It's the x value over here in the unit circle. When you start at 0, it starts up at 1, works its way down to, well, 1 over square root of 2, then 0, then negative 1 over square root of 2, then negative 1, and so forth. So let's see if we can follow that over here. It's going to start negative, let's just start at 0. 0 is going to start at 1, and then from there it's going to go to, it comes down. So I believe if I copy this and paste it here, that's going to give us what we need. Let's see here. So it starts at 1, then it comes down to 1 over square root of 2, then all the way down to 0, then the negative there, then negative 1, back up to negative, then 0, then it's, let me make sure where we are here, 3 pi over 2, we're at negative 1, and then back up to negative 1 over root 2, and then 1. No, then positive 1 over root 2. This is cosine's positive here. And then 1. So here we should have a positive root 2, and then back up to 1. Okay, and whatever it does from 0 to 2 pi, that's the same as from negative 2 pi up to 0, I think. Let's see. No. Yeah, it's reversed. So, okay, so let's do it this way. So negative pi over 4, the cosine's still positive, so it's the same as this one right here. Negative pi over 2, look at the picture here. Negative pi over 2 going this way, that's going to be at 0. So where does it hit 0? At the odd multiples of pi over 2. So let's get that. That's here. No, that's here. And here. Here. And here. Okay. Where does it hit 1? It hits 1 at 0, and then at 2 pi and negative 2 pi. Hits negative 1 at the odd multiples of pi and negative pi. Okay, so in between here is negative, and so those are both square root 1 over root 2's, but they're negative. That's that one and that one. And between here it's positive, so that's one of the that's this one. There we go. Alright, so that matches up now. And this time, the y's are going to come across again. So whatever I got there, I'm going to have the same y's here. Okay, but what do I do to the x's? I'm going to add pi over 3 to them. Alright, I need to do a little fraction of arithmetic. They've got the pi, but I've got negative 2 plus 1/3. Okay, negative 2 is negative 6/3 plus 1/3 is negative 5/3. So it's negative 5 pi over 3. Okay, I'm just going to copy that, paste it, so I'll have the over 3 part. Okay, well, I'm actually going to need 12s on some of these. Okay, so negative 7 pi over 12. Of course, you can use a calculator for this. Negative 7 pi over 12. Are we subtracting or adding? We're adding pi over 3. Plus pi over 3. Okay, get a common denominator. Negative 7 pi over 4, excuse me. I multiply the first one by 3 over 3. I can just factor the pi out. And this becomes 1/3. And multiply by 4 over 4. So this is 4/12. And this is negative 21/12. Okay, so what does that work out to be? Negative 21 plus 4, negative 17 pi over 12. Of course, I could do that on my calculator pretty easily. Just take the pi out. Negative 7/4. Let's just do fractions. Let's be sure we put it in parentheses. Negative 7/4 plus 1/3. They both have a pi, so. And I can change that to a fraction. Negative 17/12 times pi. So this is negative 17/12. Now, actually, the table over here, okay, and the original table was going up by pi over 4. Well, pi over 4 is 3 pi over 12, so it's going up by 3 pi over 12. So I can add, and so this new one is still going to be going up by 3 pi over 12. So this makes this negative 14 pi over 12, which is negative 7 pi over 6. I'll tell you what, I'll go back and reduce them in a minute. Negative 14 pi over 12. Okay, and we're adding 3 pi over 12. So, negative 11 pi over 12, negative 9 pi over 12, negative 6 pi over 12, negative 3 pi over 12, this one's 0, no, something's out of whack here. None of them should be 0. Adding pi over 4. So this first one is negative. If we do it with it's not reduced, it's negative 20 pi over 12. Add 3, negative 17, negative 14, negative 11. Oh, this is negative 8. There we go. Negative 5 pi over 12, negative 2 pi over 12, positive 1 pi over 12, Now we're just adding okay, now we're just adding 3 to the numerator. 3 pi to the numerator. So 3, 6, 9, adding 3. 3 plus 1 is 4. 4, 7, 10, 13, 16, 19, 22, 25, 28. Let's just double check that last one. So, the last one's right, I feel pretty good. It's 2 pi plus, what are we adding? We're adding pi over 3. Pi over 3. Get a common denominator, 3 over 3 here. So that's 6 pi over 3 plus pi over 3 is 7 pi over 3. If we multiply top and bottom by 4, 28 pi over 12. Yes. Okay, now let's go back and reduce this one. That one we already know reduces to 7 pi over 3. (25) and 12 can't do anything with that one. 22 and 12, we have about 11 and 6. We'll do a little reducing of fractions here. 19 and 12 can't do anything with that one. 16 and 12, we can make that 4 here and 3 here. That one can't do anything with. This one is 5 pi over 6. That one's good. This is pi over 3 here. This is negative 1 pi over 6. Negative 5 pi over 12. Negative divided by 4. Negative 2 pi over 3. And by 2 here. 7 pi over 6. And I believe we have that table in exact value reduced fraction forms and so forth. Okay. Alright, let's look at the graphs. Do I have either one? Don't have either one of these graphs yet. So I've got graph of y equals sine x, I believe. And then we want to do sine of x plus pi over 4. So where there's an x, replace it by x minus pi over 4. And in Graphmatica, just use p for pi. And so there we see it. And the amount of shift right here, okay, how much did we shift? According to this, it said we ended up subtracting pi over 4. So we shifted pi over 4 units to the left, to the right. Notice these lines are in pi over 2, so we shift by half of a grid line. And that's exactly what we did here. Shifting to the right there. If we want, we might zoom in a bit on this. Let's show at least a couple of periods here. And I could zoom in just a tad. Get that towards the middle of my screen. Copy. Paste. Resize. Got it. Okay, the next one here, if I clear everything out and start by y equals cosine of x, spell it right. Okay, there's y equals cosine of x. And then okay, that's a little over 2 periods in the positive part and a little over 1 period in the negative part there. So I've got more than 3 periods here. That's pretty good. And now I want to graph the other one. Replace x by x minus pi over 3. Let's see, Graphmatica, x minus pi over 3. And we see that this is shifted, and it should be shifted by pi over 3. No, by pi over, how much? Pi over 3 to the right. So this goes from here to here, and this should be pi over 3. This is 0.1, 0.2, 0.3 pi. No. This is 0.25 pi. This is so a third of pi is about there. Yeah, that looks about right. Okay, copy that. Paste it over here. Resize a bit, make it fit a little bit better. And now we have both of those graphs. Okay, so I'm gonna stop the video there, but just notice that in general, when you replace x by x plus or minus a number, we're shifting left or right. The formula is backwards, so if you're replacing x by x plus 6, you really subtract 6 from the x values, but you do leave the y values alone to match up pre-image and image. Whereas if you replace x by x minus 2, you really add 2 to the x's. Of course, that's going to shift the graph to the right. So replacing x by x plus or minus something is going to give us a horizontal shift. That's usually called a phase shift in these trig functions. And of course, what's going to happen if you do it on the y? If you see it this way, now this bottom one here, y equals x squared plus 5, is maybe it's not clear whether we changed x or y. But we rewrite this in equivalent form, y minus 5 equals x squared. We can see that we've replaced y by y minus 5. If we think of it that way, then the formula is again backwards. We really add 5 to the y values in the table, leaving the x's alone this time. So in both of these, we're leaving the x's alone. So whatever we have here is going to come across here, and whatever we have here is going to come across here. And it's a matter of changing the y values this time. Okay, I'm going to go ahead and work out solutions to this, but I'm not going to leave the video running for the whole thing. I'm going to stop the video. I'll post the solution set with everything worked out. If you study this, then I think you'll be able to do better on the second project, which is dealing with not only translations, but mainly stretches vertically and horizontally, and perhaps a flip over the x-axis, a reflection. And then we'll also combine this with translations and look and see what that tells us about these graphs in general.